It's great to be able to talk a little bit about what I consider a very exciting sort of frontier in the modeling space, and one in which Geoff brings tremendous insights. I'm going to be offering some slides up front here, and then I'll be turning the presentation over to Geoff, who's prepared an admirably more interesting and colorful set of slides, as he is wont. So I'm trying to record the audio from this, and I had to frob it quite a bit to try to get it get the right balance. I'm not sure the level of quality, but I figured better that than better to start rather than wasting more of your time. So the topic that I thought cover here is the use of models as learning tools for teams and communities. And some of, many of my thoughts here I've conveyed to you already. The fact that models, if used as crystal balls, are not only being used in an unrealistic way, but they're being used in a way that shortchanges their real value. The discussion here is particularly apt if we start talking about models as learning tools, because broadly we can delineate three modeling eras. My thoughts here draw a lot on discussions with Geoff, but also on some of the writings from years back by Barry Richmond in the system dynamics literature, where he talked about transitions underway in system dynamics. For those not familiar with it, Barry Richmond was a prominent and historically very, very important practitioner of system dynamics who tragically died early, and he saw great opportunities for bringing dynamic modeling, in the form, in his case, of system dynamics, to a very, very wide audience through very visual representations of system dynamics diagrams. And for any of those of you who are in the room, and I know there are many who have encountered system dynamics models before, maybe one of the most memorable features of them is that they are visually quite transparent. We have these stocks and flows arranged. You can see which variables are related to which other variables through positive causal connections via links. And it makes for a very good experience for constructing dialogue with stakeholders. But that wasn't always so. And back at MIT in the late 60s and early 70s, there was heavy use of a modeling methodology which emphasized what to one's eyes these days would look every bit like computer code, but using variable names that are utterly inscrutable, and using conventions that would make a computer scientist blanch, who was language training, such as myself. And it was particularly using a language called Dynamo, which is still extant. And in fact, you'll find no shortage of people who will be strong proponents of that language even now in the system dynamics community. But the point was, it was a very textual representation, which, if you looked at it, you wouldn't have been able to directly see anything about the model in your head unless you were a very highly trained system dynamicist. And Barry was talking about the transition between two modeling eras, where for decades in system dynamics, the philosophy had been, we have great insights to bring to the world. We can address with our modeling tools all sorts of problems. And if you have a problem which needs solving, a problem which exhibits these features of complexity, and we talk about now as sort of systems issues, complex systems issues, bring us the problem, consult with us, and we'll give you an answer to it. We'll build a model, and we'll tell you our insights, the insights that previously you hadn't been able to arrive at yourself. And he railed against this sort of mode of interaction, which he thought was really missing a lot of the opportunities for use of system dynamics, and talked about the potential for transitioning to a new era where people might not be able to build that model from scratch, might not be able to know the reasons lying underneath many, all the equations in it, but they could at least visually inspect it, interact with it, understand with it. And unfortunately, when it comes to agent-based and hybrid modeling, particularly agent-based modeling, we're still largely in an era where if agent-based models are used by teams, often they are used in the form of black boxes. We see this a great deal in the microsimulation area, where large microsimulations that are populated using data from census agencies and other empirical data sources are distributed as black boxes. And organizations that are clients have access to this interface to run some scenarios, but they can't peer inside. And they may go literally years, and I know cases like this, literally years before they realize that the assumptions in the model are far different from what they expected. They interact with the model, they can get results out in a kind of black boxes, crystal ballish type fashion, but they're not really familiar with the mechanics of the model in there, so they can't critique it, they can't refine it, and bring up concerns regarding it. So here, in this era where models are distributed as black boxes, there is model evolution, but often it's exogenous to the group. It goes on outside the group, and it's slow, particularly because the team that's using the model often doesn't know what it contains. It's hard for them to really shape it in a forceful way. And in short here, this is marked by limited end-user understanding of the assumptions of the model. Now, one of the reasons I like to give this talk in various venues is the fact that I think in terms of agent-based and hybrid modeling, we're entering an era that I like to characterize based on my background and experience as a professional software developer and as someone who teaches software engineering in the classroom to undergrads and graduate students, of what I call agile modeling. And it's marked by modeling that's collaborative across broad teams and adaptive. By adaptive, I mean it's shaped by the learning that goes on in the modeling process. It's interdisciplinary. You're building the model embedded with end users, much as they say software engineering that goes on under the software development agile methodologies is often embedded with end users. You're enmeshed in them and you're talking with them, showing them the results of your work on an ongoing basis, getting feedback. The model here is relatively transparent to non-modelers. That's not to say that the non-modelers in the team understand every little bit of it, that they understand, why you're casting things to a city in parentheses like that. They don't necessarily understand all the details, but they can look at the model and parse out a lot of the fundamental assumptions. They can understand how you're representing, infectiousness separate from latent state. And you don't have several categories of infectiousness, but rather just one. And so you're not capturing progressive levels of sickening that might lead to cavitary TB, rather it's just one category. They can look at what's in there in terms of parameter assumptions. They can look at your scenarios and see what's assumed by those scenarios. They can browse in and see some of the results of the model as it's running, and they can actually interact with it by running it themselves. And you might have end-user customized outputs, where they could go and add in a statistic over the population and add it to a graph so that they could see a custom graph of their own. So here the end users can understand a lot of the model, and because of that they can help evolve the model assumptions. It can help learn from the model more quickly. And the model here I view as kind of a living document. It's something that, far from being a rigid crystal ball that either works or is shattered upon upon the rocks of empirical data, rather it evolves with learning. It captures the team's latest best guesses for what may be going on, and when there's a mismatch found between what the model's outputting and what the empirical data show, either qualitatively or quantitative in terms of the patterns over time or patterns over space or what have you, the model can be changed. The model can be updated, and it's capturing the team's kind of current thinking. So this builds very strongly on the idea of models as thinking tools, which is kind of a philosophy that Geoff and I hew to very strongly. It is a philosophy that's more common in system dynamics than Asia-based modeling. I will say that. Although you will see people with very different philosophies in both areas. So the model here is not a static document. It's one that relates to our mental models. Our mental models as to sort of how the world works are operationalized and made precise in the dynamic model. And by running the dynamic model, we can see patterns which we then learn from in our heads about sort of how to think about the system. And then we, by interactions with the external world, collecting additional empirical data, undertaking interventions, we can test our understanding with the model against what's observed in the world and further refine our understanding and further refine the model. So it's part of this learning loop that's so important for many organizations. Okay, and the viewpoint here is very much the mental model as a takeaway. Now, for those not familiar with it, this is a central takeaway in system dynamics. Typically, many system dynamics projects try to put an emphasis on learning by stakeholders, coming to an understanding of the underlying dynamics. It is a more contentious one among agent-based modelers. I have heard various agent-based modelers explicitly eschew this and say they absolutely are totally uninterested in changing people's mental models. What they want to do is provide a good model that will be predictive. I've heard others say that it's a dangerous notion to use models in this way, which I'd never fully grokked, but almost subversive. But the point is that there are differences in philosophy within system dynamics and within agent-based modeling and elsewhere within the modeling community as a whole, the dynamic modeling community. The perspective shaping this presentation and much of Geoff's work, and indeed much of the boot camp, is the model as kind of a learning tool. And the reflection here is one that those from technical background often won't initially appreciate. If you're coming from a background in applied math or physics or what have you, there may be a notion of the model as artifact as foremost. But what you find is that in terms of the sociology of modeling, often it's the modeling process, not the model that results, that offers the greatest value. It's getting a team to reflect explicitly on how they think things operate, on their understanding of the empirical evidence, what is known, where the data gaps are, bringing to bear different perspectives, how to conceptualize an issue. Just as IT investments force an organization to kind of standardize certain processes, align, how things are defined throughout an institution, so it is with models. A VP for information technology here at our university, who also happened to be a colleague for many years in the Department of Computer Science and a co-supervisor with me with a student, shared with me that when it came time to implement cross-university IT systems, it was a time of great challenge to our university because they realized that the word student, which seems so commonsensical, was defined in something like 8 different ways in different areas of the university. Sometimes it included people who are part-time students. Sometimes it included people who were non-degree students. Sometimes it included folks who were in transitional programs into the university. Sometimes it included people who are currently on internships. Sometimes it didn't. And the different areas of the university had totally different inconsistent views. And so when it came to getting a library card, there were some rules applying. When it came to having access to your registration, was a different set of rules. And so it is with modeling, in the sense that you come to realize that just thinking mechanically and conceptually about the issue often sharpens your understanding about the concepts involved, and also often forces a team from very different backgrounds to come to common terms in terms of their understanding of a situation, or at least understanding where the differences are. Now, in our work, I think rarely among agent-based modelers, we have sought to build in to our work a heavy, heavy emphasis on stakeholder participation. And this varies on the one side of the spectrum to engagement with built models, which is something which might occur after the model is delivered. You engage with others with it who are stakeholders. They can run scenarios, have a discussion about them, learn from them, etc., learn some principles, all the way down to group model building models alongside them. Building models, literally as you're building up the model, or as you are bringing it back to them each day, they can see the model in its progress and they can provide feedback. So models here serve as, and the words of my colleague Peter Hoffman at Washington University in St. Louis, who's a prominent system dynamics modeler in the health area, he talks about models as boundary objects. And it took me a while before I really fully either appreciated or understood this term. But the idea here is that a model, far from being something that's mysterious to a team and where everyone needs to stretch themselves to learn it, there's some elements of that early on. But models can serve as a common point of reference for a team from different backgrounds. And this is contingent on being fairly transparent, so many people from different backgrounds can understand them. But when you have a model that depicts some abstraction of processes in the world, you can have people from many different backgrounds. Yes, from epidemiology, from public health, from the clinical sciences, so doctors and nurses, people from computer science background, people from industrial engineering, can all point at the same model, and they can point at particular parts of it and know they're talking about a similar process in the world. They can kind of use the model as a focus point, in short, for discussion, as a reference point to communicate. Now, this is not a small matter, because often the clinicians speak a different dialect of healthese than the public health folks, or than certainly the computer scientists. And so having a point where you can jointly reference and say, I'm talking about this area, is not a small matter in some cases, because certain words will be used in very different ways. I like to tell my boot camp sometimes in my classes that I teach, as many of the people in the room know, classes in software engineering and classes in modeling, often in the same day here at the U of S. And acronyms abound in both those areas. I almost can't think of an area where you have a higher density of acronyms than in health sciences on the one hand and computer science on the other. But the problem is that acronyms are overloaded. And so you'll hear this, sometimes many acronyms in the course of a given meeting, but what's worse is the acronyms can mean very different things to different parties. And so when I teach my classes on simulation modeling related to health, STIs would be sexually transmitted infections, right? Gonorrhea, chlamydia, depending who you talk to, might include HPV, et cetera. Meanwhile, over in computer science, STIs mean system trouble incidents. So there are cases where a computer is encountering problems or what have you, and I have seen people from computer science. I mean, that you might find it hard to imagine a case where that leads to serious misunderstanding. But there are no shortage of cases where I have seen people pass like ships in the night because they're using terms that mean different something else colloquially to the other, or just are unknown to the other. The point is that models, by being common points of reference that people can point to, they can be useful. Now the challenge here and the opportunity is the fact that models at this point are undergoing a transition in agent-based modeling to a more transparent fashion. After decades where they've been encoded with long pages of computer code in languages like C++ or Java, just written out page after page, we're now transitioning to a point where a lot of the logic of the model, a lot of its elements can be understood by those from different backgrounds. This has long been true in system dynamics, where we have these nice causal loop diagrams, and we have stocks and flows, which can be discussed at a high level with stakeholders without worrying, and we can have different structures that even people from different backgrounds can understand. Structures associated with aging chains or progressive worsening of a condition. These have been things we've long drawn in on the side of system dynamics. But even there, we have some real challenges because when we engage in discussions of these sort of tools, it is limited to co-located individuals, and it's hard to scale effectively to large participant pools. Peter Hoffman runs sessions with dozens of, for example, students from inner city schools in St. Louis, or they might be members of a village in India who come together. But once you're getting to large dozens, it's hard for people to have a voice, particularly when it's something up on the screen, controlled by one person behind the curtain, adding things in, or where it's up on a big piece of paper and they have to sort of crowd around it. There are some benefits, don't get me wrong, there's major benefits for doing it in person, but it has some limitations as well. Also, when you have multiple languages, you think about LA where you have Spanish and English as being so dominant, but also a multitude of other tongues in that polyglot city. Or here in Canada where you might have French, English, and if you're engaging in the north, Geoff for Métis communities, or Cree, or Dene. Communicating in multiple languages can be difficult if the model is in one designated language. In many cases, there's really rich discussion that goes on in these groups for building up models. And in that 3-hour session or whatever to build up a model, there's a lot of stories exchanged and justifications. And it's a very rich experience for those who have never been part of it to see people cluster around a diagram talking to each other. And sort of talking, should this go from there to there? They might talk about the latest evidence or a paper that they read, or talk about some anecdotes that they heard, and then they'll put down a link that they posit is occurring. Or they'll say, let's refactor this in this way. The problem is that a lot of those discussions, while they might remain in people's memory to a certain degree, they're lost on the diagram. And often you get hand-built diagrams that lack aesthetic refinement. These sort of hand-built diagrams can be messy. Changes in them can be burdensome because you've drawn it with marker and now you got to stretch it. Or you use sticky tack and strings, right? Or sticky tack and elastics to sort of stretch between them. And sometimes the sticky tack gives out and it goes boom and you've lost the connection, right? You have things that are pinned down and they get knocked off place, and there's limited confines of space. Just to give you a glimpse of this. Oh man, it's not in here. Oh, it's in here. It's just in hidden slides, I bet. I might be able to get it for you. Okay, well, we'll have to get you a photo of some of these sessions, which feature Geoff in some notable ways. So the vision that we have is software to support this sort of collaborative diagramming, including for causal loop diagramming, but also for hybrid modeling. And you saw a glimpse of that. And we believe it's really, really important because of this need to have models serve as boundary objects and to have the model discussed as a learning tool within teams on an ongoing basis, to have the team be able to reflect on. And a key part of that is to have it be transparent, have it be something which the team can look at and understand. Things like state charts, stocks and flows, events can help enhance that understandability. Even something as prosaic as the presence of a parameter can help clue you in for what is being captured and what not in a diagram. And this is a large part of the reason why, for all its many warts, for all its limitations, we put such an emphasis on use of any logic compared to something like Repast, which is a fine platform, but one where transparency is not its strongest suit. So this whole issue of model transparency is a big emphasis in my group. Geoff is going to talk some about collaborative modeling and notions of zoomable models that he and I have been working with. I should introduce Geoff. I didn't do him justice. Geoff is a dear colleague with whom I've had the pleasure of working now for many, many years. Geoff is, of anyone I know, the most sort of prescient, broadly knowledgeable, most widely read individual I've ever encountered in the health space. And I've found that I have profound levels of depth of understanding to learn from him on many, many topics. And so I find myself coming away with a lot of additional understanding in diverse areas from our conversations. Geoff has served in many capacities. Like me, his background is has a strong engineering element. He has a graduate degree in engineering, but he also has an MD, which I lack. I only have a wife who's an MD. He has a wife who's an MD also. Yeah, that's right. But as an engineer, as a clinician himself, and indeed over many years as a patient, and as someone who worked in health informatics for many years under the roof of IBM, he's got a tremendous amount of experience as to both the clinical sphere and the public health sphere. I look to no one else in the world from whom I can learn in this area like Geoff. So I hope you'll pay attention to his talk now. Okay, so Geoff.
Can you start it up for me?
Yeah, you bet. It's already.
Well, thanks, Nate. As usual, it's hard to recognise yourself when you're introduced. But here I am. Nate, mentioned that the modelling is in transition. Yeah, that's the good news. The bad news is I think I've been in transition all my life, so I'm not quite sure when this transition actually stops. But again, really making this journey about how do we build useful models that get used rather than just get written up and help us on our path to fame and fortune or wherever we're going. I prefer to have fun and make a difference, and that's really why I do this stuff, and that's why I come here. So what should I press, Nate?
So
I'll try pressing.
The escape is counterindicated, but you can just press these back and forward buttons. And,
all right. Okay.
And then you can summon
help.
myself or TS.
All right. So again, I've really basically I can never really remember when I've had a real job, and so it's very hard to think of retirement. So I consider myself an intellectual vagabond strolling from curious questions across, generally wreaking quite a lot of havoc. I've also had the great benefit of being really having some contacts that are really all over the place, as I say, industry, corporate, non-health people, particularly my good friend and colleague Mark Heffernan, who some of you know, had an awful lot of fun really modelling with him in healthcare. He modelled in many industries, and sort of bringing that cross-industry experience into healthcare I found extremely useful. And this is, I guess, the problem with the whole silos of academia and industry and any human organisation, that basically there are lots of problems. The solution is there somewhere else, but needs to be translated across industries, and I guess that's what I see myself as a boundary rider, a translator across industries. And more lately I've been working with a prevention institute, and we've really been trialling some of these group model building ideas. So I think I just showed you this briefly, basically say, listen, there's a kind of a mapping process that you have a concept map, and then that's the prelude to getting everything down and then moving that into a computational model like any logic. It could be any software package. But the idea of this conceptual mapping is the bridge between the mind and the computational model, just wanting a conceptual map. There's a lot of qualitative mapping that's great, but they stop at the end of the qualitative map. This is really to move from idea to computational model. So that's why it may be a different flavour from some of the other stuff. And again, we're trying to introduce people in a broader area on things that we think are really useful. For instance, the state chart. We find that the average person can just look at a state chart and get it. You don't really have to explain it. So that we found, I didn't really think that was possible until we tried it. And it just, people just get it. You don't, there's no explanation required really. So that to us is, the other thing is there are probably an order of magnitude more people, maybe 2 orders of magnitude, more people in the world who learn about state charts than who learn about stock flow diagrams, for instance. Certainly all computer science, software engineering, IT, looking at UML state charts or unified modelling language stuff. So again, just getting to grips with that. I just wanted to say we've got a couple of models, and the idea is that we often sort of salt the mind with something. So instead of starting with a blank sheet of paper, we might just put down something. If we're talking to epidemiologists, we might put down a stock flow diagram. For instance, this is kind of how we started. We're looking at prevention of childhood obesity. This is a real policy model. There's a target set by government. We've got to decrease child obesity by 5%, got to go from 23% to 17% of children 5 to 17 within 10 years, at 2025. So that's been set by the Premier of the state. And they say, now health department, you do that. And they say, well, we can't, because the best we can do is 2%. They say, well, we don't believe you. So now we're basically there to say, well, okay, what can we do? Are there creative ways to do it? And there may well be, in most of the cases we find is the target just is impossible. But again, it at least gives a basis for getting people together. So again, we might start off with a very simple model. We might knock that up and do some what ifs. So people say, in fact, we started with a much simpler model, like a 2-stock model. Normal people and normal children, overweight children, and what's the numerator, what's the denominator, and what does it mean? So what exactly do those numbers mean? And people say, oh, by the way, do you include migration or don't you? Oh, yeah, we forgot about that. Yeah. How does that affect it? All that sort of stuff.
I can't quite read out the text. What's in those boxes and those connections?
They're normal children ageing, and then they're overweight children ageing, less than 5. Children as defined by this, and then overweight childbearing women, who then, anyway, that's just a little part of the model. But again, the idea is there's a structure. And again, most of these are available, you can look at. This isn't exactly the ideal display environment. Okay, so the next part of the model we say, well, okay, by the way, overweight women have pregnancies and develop some overweight births. So again, you then question the boundary analysis. Say, well, there's no point in concentrating on overweight children. We've got to concentrate on childbearing women. I say, well, that's all very well, but we haven't got time. The deadline's 9 years. We say, well, actually, you've got to find time because you aren't going to make much difference unless you, again, the idea of prevention. And then you can say, well, okay, can we do it by just prevention or can't we? And you say, well, listen, if we reduce weight in the children that are already there, we still won't, that probably only gets us to half the target. We've got to stop the children coming in at age 5, so therefore we've got to intervene in the from conception to age 5. Again, it's a simple thing, but people just don't get it until you play out these models. Well, they get it more fully and more deeply if you play it out in a model. And then you basically say, well, okay, we've got a whole lot of stuff. What's all the stuff that we're doing now? And there are a whole lot of indicators about how much fruit and vegetables they're eating, what's the rate of... And people are measuring all this stuff. The intake of water in preference to sugar-sweetened drinks. Energy-dense nutrient for food and drinks. And again, this is all the language that these people use and are used to. And that all goes in to the conversation and these sort of maps. And then you say, well, okay, what's happening inside the body? So we've got a little thing that's kind of in this idea. Yeah, well, what do we mean by weight? What do we is it BMI? Do we need to worry about height? Blah, blah, blah. So you can have that discussion about what's in and what's out, what's measurable. Oh, there you go. So again, that's the... I think I just hit the wrong button. Yeah. It's all right, I'm back. I'm back.
Great.
So based on that, we started basically with a simple... Actually, it was 4-stock model. And then they started, this was done with experts, a whole lot of experts, a whole lot of politicians, people from the Premier's office, people from public health, endocrinologists, paediatricians, neonatologists, you name it. But again, a whole lot of the elites, if you like, the experts. And so they eventually said, well, now you've got to basically, we had sort of infants up to 5. They said, no, you can't call them infants. They stop at 2. So again, you're getting the language just right so that everyone in the room gets it right. So again, we said, well, we've got to break it down to less than 2, 2 to 5. And they said, well, okay, the way we think of the problem is you've got kids at primary school where you can intervene because they do what they're told. And there are kids at high school where you're just wasting your time. No program has ever shown any benefit in high school kids because they don't participate in anything so in this area. So anyway, so then you say, well, okay, therefore we've got to... And by the way, we need to extend it at least about childbearing women. So again, getting all that naming right and discussing exactly what you are. And the other thing, where's the split? Is it 0 to 2 or 0 to 3 or what? And again, you don't have to worry so much about this if you use agents because you can put them up at anything. So then you basically, so getting that just right. And again, this was another stakeholder. So we did this stakeholder thing. We used bits of paper and had people discussing. The other thing that I found really important was we have a recorder at both ends of the table and we record all the discussion with the participants' permission. So we capture all the language and that gets written up and then it then all gets destroyed. And, as I say, but again, capturing the language, you make sure you name everything that you've got in your model based on the language that's used and agreed on there. That makes a huge amount of difference in terms of getting useful models that might have a chance of getting used. And so this is, I guess, one of the, we've got an intern from the Premier's office working in this project, again embedded in the project, learning how to tidy up the map and put it into a computer. This is in our, again, transition stage that we've got. So this is really then looking at, okay, what's the sort of this mess about food environment? I won't go, this just doesn't go up. But again, you can, I think some of these slides I can distribute. Some of them, unfortunately, are confidential. But basically, the idea is that you get all these things and you've got a whole lot of diagrams and someone can basically make some sense out of it and massage it. And let's not dwell on it. And again, add items to it, rename them, cluster them, getting some sort of way. So this idea of some of these folders, you say, well, you know, there's healthy social norms, and then you break that down into subgroups. And so this is the idea of this zoomable sort of concepts, that you have things, you know, nested levels of complexity in it, and trying to work out which levels work with which. And again, if you want to gild the lily, which I kind of like doing, is that you can then, for different audiences, you may then make the diagram more compelling or engaging by putting in some sort of images. And I embed these images in most of these diagrams that I do. I find it. And again, you may embed different images depending on which audience you want to actually show it to. So, yeah, so some people like it, other people hate it. They say, oh, we can't do that. That looks like too much fun. This is another one I wanted to tell particularly because this is suicide prevention project we've been doing a bit of work on about the last year. And basically looking at, this is pretty much the Mark Heffernan version of suicide prevention, which is basically how do we get all the numbers to add up? He's a pretty pragmatic sort of a guy. So basically say, well, we build, can we just have a simple box where you've got people who are distressed, they decide they're going to suicide, they plan it, and then they attempt it, and some of them die and some of them don't, and then they're in post-attempt, and then they can go into intervention and whatever. And they can either be in or out of care, and some do they recover with no intervention. So that was again a pretty straightforward thing. Just say, well, you know, you tell me the numbers, how many are in each of those boxes, and what the flows are, and when you've got those numbers, then we'll think of making the model a bit more complex. They say, well, actually, we don't know 3 of those boxes, and we don't know how to find out. You say, well, with backfiguring and running this model, we can tell you that it has to be about, you know, 20 times more attempts than there are completed suicides. I say, yeah, that's probably about right. Just to generate the numbers in that stock. So the other thing was, so that's Mark Heffernan's view. You go to the literature and there's a thing called IPTOS, the Interpersonal Theory of Suicide, developed by a clinical psychologist, Tom Joyner, whose father committed suicide when he was about 10. So I guess he had a bit of a personal journey about it. So we basically said, well, how does that play out in our model? So we've got this idea of thwarted belongingness, perceived burdensomeness, and acquired capability, the means to produce suicide. So yeah, we can put that in the model, that's all very well, but it's really a model of the individual, not a model at the aggregate level. So we have the fallacy of composition. So you say, well, that's all right. Why don't we put the model inside an agent, because that's where it naturally belongs, and then why don't we mix and match the two models? So in some ways, you've got a zoomable model that's SD, and you go down and then look at individual agents. And that's kind of the idea of a zoomable model. Some agent-based, some SD, some discrete event, what have you. But the interesting thing was, yeah.
Just in terms of how that agent-based level communicates with the SD, Nate talked about having variables that communicate between the two. Would there be just one variable, and what variable
Well,
would be?
I have a very simple thing. Yeah.
Or,
Yeah, a stock is an agent statistic,
right.
basically. That's all you have to know.
So it's just the variable and that's.
You just add it up. You just add up stuff periodically, and that's what's in the stock. Keep a long story short. Flows are a little bit.
Pretty much.
Yeah, I mean, it's probably worth noting that in a stock and flow diagram, individuals are being characterized according to their characteristics, including state. And we can go from an agent-based depiction to a summarization that uses the stock and flow diagram in a very fluid fashion. Now, some portions of the model might only be kept as aggregate stocks and flows, but for many portions of our model where we have agents circulating, The stocks and flows serve as a means of summarizing, characterizing the agent population. And they can do so in a quite transparent fashion. So we can have flows based on the number of agents that have transitioned from this state to that state in some way, and or stocks, the number of agents that are in this certain, have this certain characteristic right now. And it turns out that we've explored mechanisms for doing this, but it's actually fairly straightforward to do with some basic mechanisms that we can talk about later. Okay.
I have a conceptual question for you. So in yours, on the upper rung, you have the attempted suicide, but in the lower rung, when they're actually in care, they can commit suicide, but they don't attempt it. Was it just you didn't have an attempt stock for the in care because it wasn't of interest?
Oh no, they rotate back,
Okay.
round up to the top thing. The short answer is yeah. And again, getting that logic just right and saying, well, how are these people? Do we have to worry if you've already attempted suicide? Do you go back to the at-risk population? We decided no, you're different in terms of interventions and in terms of the rate at which you may, the risk. And there's some reasonable things to do that. But the interesting thing about this one is that this is again a fairly political policy. How do we improve suicide prevention policy? The National Mental Health Commissioner is one of the sponsors of this project. He said, well, if we want to get serious funding for this model, you've got to do user participation. And so there's this great sort of, there's this strong movement that says nothing about us without us, so that those who are affected by a policy need to be in the room when the policy is being designed. So get rid of the expert. Well, the experts are not enough. Yeah, sorry.
This is more general question, but I was wondering if there is a measure of worthlessness, adding complexity to the model. And this is along the line with mean variance trade-off in statistics or econometrics. So my question is basically, how do you measure the worthlessness of adding more variables or more features in your
Well, what we normally do is we add it and see what happens, and then find out that it's not that relevant for what we're doing, and then
how do you find that?
we pull out. Well, we do the experiments, or we say, well, we can't get the data. Again, it's a matter of iterative development. The other reason we model in detail is because people believe that some parts, particularly this is policy work in general, we're doing, some parts are important, particularly the part they do. And often you've got to put it in the model, and they'll say, well, actually, it doesn't seem to make much difference for the question that we're trying to answer with this model. So, yeah, I'm now convinced that you can take it out. And again, this is the idea of this is a model for learning. So, well, what are the relevant things for this particular question? And so this idea of, again, zoomable in terms of we get a lot of complexity, and then we try to then work out what most of the insights of the model dynamics show. So can we have a much simpler representation, and can we do that in some interactive way that build up in the model, and also capture that process of iteration and the learning and why we tried this part and then why we actually got rid of it. So I would say it's just more just suck it and see. And again, you've got some metrics about, from the experts who say, well, you've got to have this level of confidence interval and whatever. But again, it's, to me, again, we want to build useful models that gets used. And George Richardson tells a lot about that validation of a model is a social process. That how do you develop confidence in a model so they will actually act on the results? And that's not a technical problem. It's a social problem. How do they trust the model? And this is a lot to do with the engagement. And they don't understand the model, but they know that someone they know and trust as an expert does understand. They say it's okay, or they say, well, it's okay for this purpose. But again, this is always based on the purpose of the model. What is the purpose of this model? The purpose of this model is to help make better policy decisions. Again, this isn't a model for publication, which would be a completely different model. Well, you may take lots of confidence interval runs to get it published or whatever.
Yeah, and there are techniques that we'll be learning about in the next 2 days, which can partly address Cornelia's question at a technical level involving sensitivity analysis, which can provide evidence that, you know, breaking this extra level of heterogeneity out does not yield material changes in the findings being examined for as the focal point for this investigation. And there'll be a presentation on sensitivity analysis as well as some related issues within the next 2 days. With showing how it's done in analogical and very concrete terms.
This was a slide I had in the talk I gave some time ago. I think it might have been Monday. I can't remember that far back. I guess one of the problems, we've done a lot of modelling projects, and the problem was that the modeller probably is the person who learns the most on the project. And how do you bring everyone else along? This is the real problem with these projects. And this is what we say, well, how do we bring people along? You know, what's the point of us knowing it? We don't have the power to change the policy. So this is really, and a lot of it is about group model building. Everyone makes their own journey into understanding. They're all coming from a different position. They're all starting, you know, it's the old joke about, you know, the Irishman being asked the way to Dublin, he said, well, I wouldn't start from here. And a lot of these people are in positions where I wouldn't start from, but that's where they are. So yeah, you've got to take, how do you get them? Yeah, and they've got to be comfortable with that journey. So a lot of the modelling is, again, what do you put in, what do you leave out? It depends on the journey these people are making. And in some ways you can intuitively understand what that is. And after a bit of experience you find, well, therefore I'm going to, the way I order the project and what do I focus on, as you say, do I need to really, you know, nail all the technical stuff, or can I be kind of a bit more free and easy in some of the sort of indicative type ideas? And again, just understanding that. But again, you know, what's a modelling project that's really, where you really go to perhaps have fun and make a difference? What does that look like? And these are the sort of things we came up. I was really on my way here in my jet lag state. I moved to I was talking to a friend in Minneapolis, and we were talking about what's the sort of ideal group to work with. And so we came up with this list. And then, yeah, what do you work on? There's no shortage of persistent chronic problems. The high point is a lot of persistent chronic problems are maintained by tampering, that people fiddle with things. And again, Deming talked a lot about the tampering. Again, this idea of, he called it the theory of profound knowledge. What do you need to understand? Have deep understanding rather than some superficial tampering, responding to noise rather than the real basic dynamics of the system. The powerful sponsors with a clear agreed purpose always, that focuses the target. The idea of multiple interacting feasible interventions, that's really where this comes. So, well, okay, we've got these interventions, how much do we spend and when do we line them up to get the sort of synergistic effects? We don't want them cancelling each other out. We don't want to have project fatigue where you just got too many things being foisted upon the people in the trenches. There's a whole lot of things you've got to understand. A well-defined success measure what and when, and this is where these Premier's priorities thing come in handy. But often you find halfway through the project they've set the wrong target, but hopefully they can come to that decision and then find a way to gracefully change it to something more practical. Again, they have to come to that journey themselves. Again, this idea is that a lot of people, often we find there are people who have been working at something for a while and not really getting very far. And a lot of people in suicide prevention say, listen, we spent a lot of money, billions in the last decade, and we really haven't made the slightest difference. So in Australia, where we really don't have a lot of guns, we basically, suicide, the only thing that probably have made a difference to suicide rate has been the use of catalytic converters in cars. So that people, it's much harder for people to kill themselves, locking themselves up in the garage and turning on the car. That's probably the only thing that's made a significant difference, which is complete. All the health-related mental health stuff, that really very little evidence has made any difference. That's a bit sort of a sobering sort of thought. So again, the people, this idea of we really have to do something different among this core group of diverse, well-informed individuals. And the ones who are already working well together, it's very hard to build a team around a modelling project. It's threatening, it's different. But if there's a team that's already in place that they get on and trust each other, they're cross-disciplinary, adding a modelling dimension to what they've been doing can be just fantastic. And again, where these interdependencies are appreciated because they've got these cross-disciplinary teams. And that's certainly the case in our gestational diabetes project, where we've really got a group of data experts, public health people, political operators, endocrinologists, neonatologists, all sort of group of people who've actually been working together maybe over at least a decade. And the other point is that there is a real commitment to say, listen, this isn't just a model on the side, this is a model we're actually going to use because we realise we need it. So that was sort of that, and I had a few slides, but I don't think I've got time to go into them. This is more on the zoomable model. I don't know that it's worth going through. Nate, what do you?
Can I ask you, when the word zoomable, are you just talking about using kind of the insight maker capability to zoom in on different aspects of the model, or is there a more formal definition?
There's a more formal sort of journey, I guess. We've had this idea, again, this idea of, you can see it in, it's really the difference between when you sort of the hierarchical city population model. You can kind of see the idea there, but in some ways it's more about, okay, that logic captures these different layers. I guess the idea is, and it's not an uncommon one, perhaps I could look at it. So where you've got a system of connected decisions, the decisions are all there. So if you look down on everything, you've got people making strategy decisions and tactical decisions and day-to-day decisions, and they're all integrated. You can sort of look at, down on the world.
Right.
And you've got the idea of you've got population health, service management, and clinical interactions all at different levels in health care. And again, multi-scale all comes from the ecology literature, really. Called the Stommel diagram, I think, in their thing. So you've got this idea of go from the molecule to the universe, from centuries to seconds, if you like. So scope and level of detail, time scale and scope. And then you can basically clump them into these three areas. And I guess one of the reasons we thought of it is this idea of, well, some people are thinking in stocks and flows and aggregates, and some people are thinking in individuals. And we basically, you have a group of policy makers and clinicians basically in a room, and you basically have a stock with 5.2 patients in it. Well, you often lose half the room. So, well, you know, how can you have 5.2 patients? Well, this is an abstraction. So the idea is zoomable means how do we zoom through levels? So that's the idea of multi-level. What's a level? A level is a layer, a level of what? It's a level of organisation, often in organisational theory. It's a level of abstraction. It's a level of, is it ideas? It's, what are these levels? They're different things to different people. So that's the idea of how do we introduce the layers? Again, this idea of a layer. I guess this is kind of the thing that this really came from something, body systems modelling with a virtual human physiology, where they basically have cellular dynamics, tissue dynamics, organ dynamics, body system dynamics, body dynamics. And this idea of having fast composite models, which you could actually, when that composite model starts to sort of go a bit wrong, you can then hive off a detailed submodel which would capture the detail of maybe the part that's going wrong, and then aggregate that up and then be able to do that. But you can't basically get your brain. So that's really this idea of, that's where it really came from, the virtual human project. Well, that's where I came across. The real problem I find is that, and we've sort of modelled little prototypes of that, and most of them hierarchical, as you've done in the city population one. But this is the real problem, is that most of the things we're interested in are overlapping. And Sarah could talk about the modifiable aerial unit problem, but at least you've got contiguous boundaries that, but what if those boundaries are moving in and out all the time? So it's actually a network, and the idea is, this is just, so things we're interested in, sometimes we're interested in indigenous population, sometimes we're interested in gender, sometimes we're interested in location. There's all sorts of a network of things that these views. The other thing is, think of these, this is a static picture, but think of these as being searchlights, that the boundaries can open and close depending on whether we want to zoom down into the individual level or zoom up into the thing. And some of those things will then have different cross-sectional relationships. So that's the idea of zoomable, that's zoomable and dynamic. So how can you zoom on the fly? And again, the Google Earth type idea, how can you zoom around? How do we bring back and in? And how do we actually, can we sort of flip in and flip out different models depending on which level we want to look at? See, our brain does that perfectly splendidly. We can look on at this and we decide pretty much what information we block out while we concentrate. And that's kind of the idea. What do we block out, what do we concentrate? But what do we just keep a sort of peripheral vision about at an aggregate general level?
Can I just put one thought up here?
Yeah?
So I can share a little bit of
yeah.
We did a ED patient waste and flows initiative. I was working with a group there, and we were doing some initial pilot work on building a model. And what we found is that the first model that we tried to build was this sort of 30,000 foot system dynamics model that kind of tracked the whole system. So that was one level that we were focusing at. And when we were building a model in that level, the types of data, the types of terminology, the types of structures, the type of causal loops that they saw, and the way that we described the system sort of matched that level of understanding. But then when that model was when we sort of got, and so that model was a bit like the suicide model that he showed, that it was very, very, very simple, but it kind of showed in a very clear way how some of the data kind of depends upon other data, and maybe this was a way that the researchers, the experts in the field they weren't quite familiar with looking at that relationship. But again, it was pretty simple. But then once we didn't have a zoomable architecture to be able to sort of dynamically go in and out. But then the next model that we built was sort of an individual hospital, discrete event, people coming in, people coming out, times of treatments, numbers of doctors. And so then the structures that were really useful to get insight, they were different structures, right? So now instead of this overarching system dynamics model, we had this underlying discrete event model. And so the structures that were useful to generate insight were different, as well as the terms that they were using and the statistics that they were gathering. So like this idea of being able to move in and out is so that for your question, and even ideally I think in a world for your part of the question, you would go to the level that was sort of relevant for your question, and you would use the tools and the terminology and the metrics at that level to get into the insight that you required.
It also, so that for people unfamiliar with it, this was a very large project across Saskatchewan. This is the modeling component of it. It's a multi-$100 million sort of major investment by the government here. And this is being used to sort of try to help inform the selection of priorities. So you were working with very cross-sectoral or cross-disciplinary.
Right.
It bears noting that the second model you built was created after that first model had been sort of had much of its understanding elucidated, and I think some insights from that first model certainly shaped the later model, and some of the limitations of the first model in terms of the questions you could for which you could secure answers.
Which then goes to show that if you're able to switch back and forth between these different levels, you know, the sort of what you understand at the top level will inform what you seek in the middle level, will then reinform what you seek when you go back to the top level. So being able to go back and forth. I know we're talking about it in the abstract, and I think part of the reason is because we don't really have a software mechanism package that we can look at that makes that process really easy. We had to build two separate models and flip back and forth between them.
We've got one, but it's not. It's in progress. We've actually got one for the suicide project. We've actually built a prototype suitable model. Well, it's about our fourth attempt.
Yeah, and maybe it will just be worth saying, because as you know, we a year or a little bit more ago, Geoff and I helped guide a talented model implementing student in trying to explore this idea of a zoomable interface to a model. And part of that idea was the same model in different meetings. You might want to communicate with people with very different levels of interest. And so you could, for a model with the clinicians, you would zoom in to the individual level, whereas for policymakers, you might be dealing with them at the very high level interface. Yep. So there is a sort of concrete way in which it ramifies in terms of the interface.
Yep, yep. And Josh, this is a sort of more formal definition. This is something one of my PhD students about 2006 put together in her thesis about this idea of, let's say you've got networks of things happening at different scales, but you just look at it, and then you can then put them out, and sort of some of them are happening at some different level of abstraction. And this idea of you can have some components that retain their identities, but others become an emergent, what is called a compound whole-on. So the whole-on stuff's interesting because something that can be simultaneously a whole and a part. So it's a whole in itself, but it's part of something else. So it's actually this idea of cross-scale sort of stuff. And again, there's a bit of literature. This all comes from realist evaluation stuff, critical realist, if you're into the, depending on which philosophy science is your flavour. I won't go into that. And again, it's based on this levels within levels, my dynamic modularity thing. The other thing is there's some stuff coming on about, okay, how do you analyse these scales? What some tools? What are the scales? This is something pretty grassroots innovation in land use, really. And they're basic, and this seems fairly similar to some of the health things. I'm just looking at how to adapt this and put this in, and go. So you go through some formal process. So, well, let's see, which scales are interested? Where are we? How do we locate it? Yeah, how do we get coordinates of both time, space, and kind of layer of abstraction? The only problem is these layers are not, people's layers are not, you know, that people, you think you're going down and they think you're going up, even in abstraction. It's not an easy issue to solve, but we're making a bit of progress. And so I've got a copy of that thesis somewhere. And again, it's sort of, how do you sort of put together all this learning over lots of projects? Can you actually contributed to different levels of a model. And can different people curate different parts of the model? Can they have data that they link with the model? What would this look like in a grand, world domination view? That's what I learned at IBM, how to plot world domination. I think that's about it. Yeah, and again, the idea of, I kind of like this diagram, yeah, you can enter this world through, research design, theory building, or empirical stuff. Yeah, but how do you put together this mix of theory and data? That's why I had that there. That's probably it, I think. Yeah.
Okay, so. Great. So wanted to announce for the afternoon on this day, and likely for tomorrow and Friday as well, we're going to try to reserve the afternoons extra time for the project work. So we're going to go back. There's going to be no lectures this afternoon except an optional lecture towards the end of the day on continuing the discussion of Java. Okay, so I'm hoping we can use this to drive the project forward in terms of engagements and meeting. And you can go off there when you arrive to the various small rooms. If you need to be let into any room, Kurt has the keys right now. I will have the keys after I get back there, and you can grab us, and we'll be sure to open up spaces for you. But I'm hoping that the next few days we'll be able to, with you acquiring a lot of the basics of understanding the building blocks, you'll be able to drive forward the projects. Okay. So I'll be circulating. I know I'm going to be discussing already. There are plans for 1 or 2 groups for me to talk in detail with this afternoon, and I'll try to get around for additional ones as well. Okay? Thanks very much.
Because you had the philosophy slide, have you done much with, and you sort of mentioned kind of ways of epistemology, like ways
Okay,
of
great,
understanding
great.
the world.
So yeah, I may go back.
Have you done much with that?
Yeah. So you could say, if you could just say.
No.
You'll contact him this afternoon.
Well, yeah, I'm going to be by this afternoon.
I like the idea of
Before 3:30 or something.
Yeah.
well, it's really Vildavsky stuff like culturalist theory about how to see risk and safety stuff. That's a bit I like for healthcare. All we've really done is sort of try to conceptualize that bit. I haven't built a model. Trying to find a project.
Oh yeah, package
Somebody's interested.
Totally.
The idea is you've got
Okay, thanks for letting me know.
individualists, hierarchists, communitarians, and fatalists. And how does the tension between those people actually create?
Not directly linked like
that's
the
really
ADI and TB.
Yeah.
And how do you move
So
people?
why not we build a model for the human body itself instead?
Different idea.
That we can use
I
it
was trained in
as a model.
So
Yeah, the
it's
challenge
declared it
is,
to be, but it wasn't really a solid constructor.
challenge there is there's so much complexity
I know that I
in
can say things
characterizing
that
the
tell me
whole
I was
human
wrong,
body.
and that's
That would be
if I can be wrong, then you're.
Yeah.
that would be
Yeah.
very, very
Nothing
challenging.
is
There are people who are
And then like
seeking
in
to
my
do it just
software
as
program, I started
a
realizing
mammoth
doing all these
and you need
interventions,
to simplify it
depending on where
somehow.
the cutoffs are on your model or your
Um,
ways of understanding.
but it's good that you're
you know,
thinking.
Shouldn't be a really
It's changing your outcomes, and nobody really had much interest in that. So,
Especially for
Oh yeah, no, it's an area of great interest.
How's
that
that?
I've done. It's interesting also that there's a little bit about how that actually plays out in
people into
right.
the car and it has the
maintaining critical
response.
infrastructure.
Right.
So
There's a guy named
if they can
Emery
do it,
Rowe
we
who actually
somehow
happens to be
can
the father of Scott
pretty
Fortman
simple
Rowe, who
idea
built
of
Insight
task.
Maker.
Mm.
He's
Simple
got a
device
wonderful
to
book
tackle.
called
That's interesting. Yeah. Mm.
Because they have already
The idea is
created
that, well,
very
what
simple
we've got in the
thing.
world
Just as for
is
another
these
purpose
methods
which is
help
not
together
in some electric model like what we
yeah.
You're talking
That
about
would be
physical
interesting,
models.
because in that
Yeah.
healthcare grant,
Like
like,
actual-
So if they can do it, I think somehow
and then, but
we
at the same time, funding seems to go to things
they
that I
can
don't
still
want to be a part of.
it
Oh, yeah.
may not be
No, no,
Um,
we've got
exactly our
you've got to find funding
is
and then
satisfied for some of the
work it
situation.
then channel it
And
into what
maybe,
you're interested in.
very good
Or better still, somebody
base
else
for
finds
the
funding.
further development.
Mm.
There's not much division. of
Well,
labor.
let's talk about that separately.
Research.
I think that's it's an interesting
Also with the
notion. I
suicide,
can comment
have you
more on
actually
it.
pushed that yet?
Okay.
No, we haven't.
Let's see if we can have a
We've
time
done
to discuss
a
that
couple
in the
of
next few
proof of
weeks.
concept models.
Maybe later.
Now
Okay.
I've got
Okay.
Okay.
on the sort of a
That'd be
smelly
great.
and oily rag.
Thanks very much.
Mostly voluntary.
And, yeah, just
We're
feel
now
free to go
waiting
when you
for a
need to,
proposal
okay?
to roll
Okay.
that out nationally.
Okay, cool, thanks.
Big. Whether we get it or not, who knows, but sure enough. And then we could find.
Geoff, I'll be back shortly.
Yeah, doing some of this ideology stuff, yeah. But I think, yeah, it's a fascinating, yeah, it's more about, a lot of the system dynamics people understand the sort of Simon's bounded rationality where you have information filters, but I think this idea of what you just choose to completely ignore to justify, how do you justify what doesn't upset you? And what, and one group, they just don't see a person begging for money in the street. I come to some North American city and you've got all these people begging, what's wrong with this place? What's wrong with this place?
Yeah.
But again, a lot of people just stop seeing it. They just don't even notice.
Yeah.
Because, well, it's their fault. But you snooze, you lose. Again, these sorts of, how do you, not only you don't filter information, just completely reject it. And a lot of the climate change denial stuff and vaccination stuff. There's some nice papers written on that.
Yeah.
That are applying cultural risk theory in particular. And I've got a couple, and suicide, the idea of suicide, what's the right number of suicides? Is it 0? Or you say, well, hang on, you want to kill yourself when you're, 75. Why not?
Or at the same time, if you think about even if like.
And you thought about it,
Yeah.
you're not, you're very sorry. Again, assisted dying, again, these ideological battles about why do people.
Well, I tend to push it even further just because I wonder, like, if for example, if we prevented 100% of suicides that were age 35, that doesn't mean that they're going to be in the world. What is the chance that they're happy and successful, or are they contributing to the world?
There are fates worse than death.
Yeah.
Yeah,
And
exactly.
so it's interesting because in the suicide literature, they tend to focus entirely on those fix it, mental health, care and all that.
Well, again, it's incredibly over. I mean, the participation workshop we had, I didn't quite mention it because I lost the slide. I thought I had a slide in there, but I don't know, in my brain. But we actually had a whole group of people who all attempted suicide. That was those who were affected group.
Yeah.
So you say, well, how do you see it? And it was quite different, what the experts told us.
Yeah, I think it's nice when they actually people actually listen to those groups because a lot of times they'll want the people who are physicians.
Oh yeah, and this is again you don't want to use it as a sort of instrument of power. Again, it's sort of offset the power of balance.
Because I did suicide prevention stuff just as a volunteer for a lot.
All right.
And then I've known a lot of people previously that led to that. So, and then I was assaulted during high school.
Oh.
I said I was suicidal, but it was really that I didn't want to turn in the guy that had assaulted me. And so then I got put in the suicide ward in Texas it's mandatory 3 days, so I got admitted for that. But they knew something was different, so they treated me differently. But it was interesting to see the collection of
It's a sobering experience.
yes. So it's just been.
I work well. I work in psychiatry. Training into a medicine specialist who rotates through psychiatry. Again, it's theological. But it's just a totally different viewpoint. But it's again the problem is it's just so emotionally charged. Particularly if you've had a relative or some person else. The people who are attracted to the field are often motivated by it. And that's you've really got some really heavy duty emotions associated with it. conflict inside a model. So if you think like this, if you think like that, then how will you interact? So you have these people with these worldviews that they're captured as different types of agents.
Yeah.
So you build this synthetic world which takes account of all of that.
I'm gonna try to figure some more, because I've been thinking just like it's a model they my actual work, which is like diabetes or
Yeah.
traffic safety stuff. But I've been thinking about some sort of like predatory version of a model of humans where
Thanks a ton.
some people I think tend to attract predator types, and it could be that there's something that radiates out that I haven't figured out how that would work. But
Yeah. No, I think, well, we should explore that because that's an area I'm really interested in. I think the place to put it is the debate between preventing suicide in the young and assisting euthanasia in the elderly. So that this seems to be the balance of society. We just again like a lot of European countries. I think Canada's just got the assisted dying bill, doesn't it? Is that national or is it one across it?
It's very contentious now.
Yeah.
Yes, there was a vote, and I think it was national.
Yeah.
And you know, Canada tends to be a country with a lot of emphasis on consensus, and I think partly because of that, I think it's going to be. I think what's really started is a large conversation about it, you know, how to proceed in the safest way. And my guess is, given the way Canada proceeds with these things, it'll probably be a slow process till it actually ends up rippling through the reality.
So again, reflecting that those sort of again, how do you put values again, which are highly individual? How do you put them in a model?
yeah.
Value certainly isn't quality divided by cost.
Even if you have a rational model where you were programming was like fatalistic versus
Exactly. Yeah. So that's what I want. I want fatal. And there are a lot of people that say that actually we need, you know, it's a bit like the US isn't good, but the communitarians need the individualists and the hierarchists need the individualists to justify their own stuff. So you've got to say they're wrong and I'm right. That's part of the justification. So each needs the other.
Yeah.
And you don't want, and you'll never get everyone the same, but you'll get these different mix. Again, you know, the fatalism in Russia, you know, after the fall of the Soviet Union, unbelievable. Just how does that change? The other interesting thing is the middle literature says that people have different worldviews depending on different parts of their lives. So you can switch your you may be fatalistic in some things, communicatarian in others, individualistic in others.
Yeah.
And now your brain really hurts. That's really getting complex.
One of the areas that I've been particularly interested in, but I haven't figured out how the model is, like how do you gauge that within the systems models to reflect what interventions are used and
Oh yeah. Well, exactly. Which but there's a nice literature on the vaccination